Welcome back, dear friends. After this interesting discussion on net present value, we would learn another interesting concept which is called as IRR. IRR is the internal rate of return method. So we said that as the outcome of this course which you are taking, you would be in a position to audit independently. I mean the energy audit and solar proposals, you would be in a position to financially evaluate independently using the simple payback period method, using the net present value method, and third is using the IRR method. So in this lecture, we would be learning this third method, very interesting method called as internal rate of return method, IRR. So what is this internal rate of return? Internal rate of return you would understand only if you have understood the concept of net present value. Net present value, if you remember our discussion which we had, was calculated by assuming certain discount rate. So the discount rate was given and we had calculated the present value. And once you got the present value by assuming a discount rate as I, let us say this I, what we did was we calculated the present value of all the cash flows, the future cash flows, and then we subtracted the initial investment. So that is how we got the net present value. Now in this expression, we were given I, we were given N, the number of years, we were given the cash flows every year, and we were also given this information of initial investment. So with this data, it was possible for us to calculate net present value. Now, internal rate of return, in this method, your one term is unknown, that is I is unknown. I is to be found out, and how do you find this I? So for finding this I, we need to substitute the value of NPV as 0. So mathematically now it becomes very simple. You have an equation where this value is 0 and you have only one unknown, that is I. And once you calculate that I is called as internal rate of return. Okay, so technically speaking, now you have understood how to calculate internal rate of return. How do you calculate internal rate of return? The steps are, we need to know the cash flows. So let us say that is the period of 3 years. So you know cash flow of first year, cash flow of second year, and cash flow of third year. You also need to know the initial investment, right? And you know the number of years. You don't know the I, that is internal rate of return. And so what you do is that you find the present value, you write an expression for present value. You won't be able to find, but you can write the expression for present value as CF1 1 plus I raised to 1 plus CF2 1 plus I raised to 2 plus CF3 1 plus I raised to 3 minus initial investment and equate it to 0. By solving this equation by trial and error, you will get the value of I, and you just say that this value is the internal rate of return which you are looking for, right? So mathematically speaking, it is very simple. Now what it means conceptually? Conceptually, what it means is that we are eager to find out when this initial investment is recovered. Okay, we are interested by finding IRR. We are interested in finding at what rate of interest will the initial investment be recovered. Okay, so that rate of interest which would give us the savings which is equal to the initial investment, that is called as the rate of return. Okay, and this is very logical, that at what rate you are getting the money back, that can be understood by equating this present value CFN upon 1 plus I raised to n with the initial investment. Okay, so if you are able to equate this annual cash flows with the initial investment, and if you get that I, that is the IRR. And why do you calculate that IRR? This is because it is a good way of judging different investments. Suppose you are having an investment A and you have another investment B. Investment A is giving you some savings A and investment B is giving you some savings B, right? So if you want to make a decision as to which investment should I make, because you have a limited amount of money, so whether I should go for a project which is going to give me a return of savings A, or I should go for a project with the savings B. For that, you must understand what is the returns which you will be getting because of that investment. So IRR is a good way of judging different investments. The project which would give you the highest IRR, highest rate of return, highest internal rate of return is the project which we should select. Okay, so IRR enables us to find out the rate of return of the project, and generally speaking, it is used for comparing different projects and for making wise decisions on economic basis. Okay, the project which is going to yield highest IRR is to be selected. Okay, now this will be more clear as to how do you calculate IRR by taking this very familiar example. Let us say that there is a proposal, there is a household, and this proposal is that you need to replace the electric heater with a solar water heater. Okay, the typical tropical climate, and people use solar water heater for heating. Okay, and this has to be installed in place of electric heater. The solar water heater, let us say that it's worth, I would be using the Indian units, Indian national rupees. You can convert it to dollars also, depending upon the capital cost of your currency, you can use that value. So let us say that the capital cost in India for a solar water heater, which is planned to be replacing the electric heater, is 20,000 rupees. Okay, and let us say that because of replacing an electric heater with a solar water heater, some electricity is saved. Obviously, some electricity would be saved. The electricity which otherwise would be used in the electric heater would not be saved. And let us say that saving is about 2 units, 2 kWh per day. Every day you are saving that. And let us say that about 2 kilowatt hours per day is the saving. And that saving, if you want to understand in terms of money, you must know what is the tariff rate, the rate at which the electricity is bought. Let us say that tariff, the rate at which this electricity is bought by the consumer, is 10 rupees for every unit. Okay, let us say. And we need to assume the life of solar water heater, and let us assume that as 5 years. Okay, so the question is now to estimate, to calculate the internal rate of return. So how do you calculate that? So if you understood this, you pause this video and you calculate and then check the answers. Okay, that is a good idea. So we'll be solving this now. Okay, right. So solving this, what is the data available? The data available is initial investment C naught. Let us say C naught means the initial investment, and it is, let us say, 20,000 rupees. Now we need to calculate the savings. Okay, every year you'll be getting savings. So how do you calculate the savings? So we calculate the savings by assuming that the solar water heater is functional for 300 days. Okay, so 300 days, how many units it is going to save? So 300 into 2, that is 600 units it is going to save over a period of a year, right? And let us say the tariff remains 10 rupees per kWh, and that is remaining 10 rupees kWh per kWh for the next 5 years. The tariff remains the same. Okay, in actual practice, you know that the tariff would increase, right? But we'll make a simple assumption that the tariff remains the same for the next 5 years, and that is 10 rupees per unit. So it means that 10 into the saved energy, that is 2 into 300, that is 600. So 10 into 600 comes 6,000 rupees is the savings. And this savings you get at the end of year 1, year 2, year 3, year 4, and year 5, because we have assumed that the life of the solar water heater is 5 years. Now, without considering the discount rate or the time value of money, you would have simply said that the savings is 6,000 into 5, that is 30,000 rupees, but that is not correct. Okay, that is because we had already discussed the time value of money, and we need to consider the discount rate. So how do you calculate now the IRR? For finding the IRR, what we need to do is that we need to just assume certain value at the outset. We will assume certain value of discount rate. So let me assume that some discount rate IRR is 10. Okay, so if discount rate I is 10, then I find the present value for the savings. So 6,000 upon 1.1, that is about 5,400. 6,000 upon 1.1 square, 6,000 upon 1.1 cube, 6,000 upon 1.1 raised to 4, and 6,000 upon 1.1 raised to 5. So this savings, if you add, okay, that totals around 22,000, 22,700 something, right? So these are the savings, and this savings you need to equate to the C naught. Now you will find that the savings are pretty higher than C naught. It means that the net present value is not zero. Okay, net present value is positive because your savings are greater than the initial investment. So it means that your I value is 10. The value of I, which is 10, so this I is not equal to IRR. It is something different. Okay, so we need to now change the value of I till we get the NPV is equal to almost zero. Okay, so what we do is that, so let us say, let us just generalize this with the help of example we have taken, but I will just now discuss the steps. So what we had done was, we had assumed some value of I and we found the NPV, right? Now in our case, we got that the NPV is positive. Then what we need to do is that we get an idea that because the NPV is positive, it means that the returns are greater than the discount rate which we had assumed. So the discount rate in our example, we had assumed to be 10. Okay, so because we have got the net present value as positive, we would increase the value of I. If you increase the value of I, the net present value would decrease, right? So in our problem, we should increase the value of I, and then we should increase it in a manner such that the NPV becomes zero. If that happens, then that I is the internal rate of return. Sometimes it would also happen that the NPV would be negative. Assuming certain value of I, you would get the NPV is negative. If NPV is negative, it would mean that the returns are less than the value of I which we had assumed. Okay, so we need to now decrease the value of I. And once you decrease the value of I, that value of I, which would give us the NPV is equal to zero, becomes the IRR. I guess that it is now very clear to you that if you get the NPV as positive, the value of I has to be increased by a trial and error method until the NPV becomes zero. If you are getting the value of I as with the value of I, if you are getting the NPV as negative, then you need to keep on decreasing the value of I till the NPV becomes zero. Okay, and that value where the NPV is zero is your IRR. Hopefully, this is very clear to you. In the next class, in the next lecture, we would be taking a case study which would help us appreciate this IRR better. Thank you very much. Bye for now.